It's a neat way to travel.
This is Rocket Park at the Johnson Space Center in Houston. This is a Saturn V rocket, the kind that carried the Apollo astronauts to the moon in 1969. It is proof that science fiction can become science fact. The cast and crew of Star Trek's Enterprise aren't the only ones to boldly go where no one else has gone before. We've already begun to explore the galaxy.
Space, the final frontier.
Roger, 7. You have a go. At least 7 orbits.
20 feet down, 2.5. Picking up some dust.
Yeah, read you loud and clear. How's it going?
Roger, the EVA is progressing beautifully. They're setting up the flag now.
Ignition. Right away, Houston.
Science fiction very often leads the way to science fact, like going to the moon, for example. Somebody was writing about that 100 years ago.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
I wonder if John F. Kennedy would have been in a position to say that had it not been for the science fiction writers 60, 80, 100 years before suggesting that as an idea. If someone hadn't dreamed that, would the scientists have been able to come to him and say, we can actually do that?
A couple of years ago, NASA was, the new NASA administrator charged NASA with coming up with a NASA motto. And there were a number of us that proposed that the Star Trek motto should become the NASA motto. You know, that's exactly what NASA's about. It's about exploring strange new worlds.
To explore strange new worlds.
To seek out new life and new civilizations.
To boldly go
where no one has gone before.
We didn't carry the day. A lot of people thought that that would be a little too corny. But I thought every American knows that's a NASA motto, and they know it because they've heard it for 20 years on Star Trek.
Gene Roddenberry created the original Star Trek series back in 1966. The Soviet Union and the United States were hotly engaged in the race for space. Satellites shot into orbit. The first man walked on the moon. And probes sailed to Mars and on to the far reaches of the solar system. Scientists were making great advances in space exploration. But none could compare with Roddenberry's invention, a starship that could race across the universe faster than the speed of light.
There was always an attempt to have a potential scientific foundation for anything that we posited as real in the show, although we were doing science fiction. The idea was, could this possibly someday be done? Could this possibly someday evolve into real science?
What the hell is happening?
The barriers between quantum realities are breaking down. Other realities are emerging into our own.
We did an episode in The Next Generation called Parallels that took as its point of departure an interpretation of quantum mechanics called the many worlds interpretation of quantum mechanics, which says that basically every time that you conduct an experiment or every time something happens in the universe where there's more than one possible outcome, all of the other possible outcomes actually happen, but they happen in different parallel universes that are constantly branching off from our own.
When Worf's shuttlecraft came into contact with a quantum fissure, I believe its warp engines caused a small break in the barriers between quantum realities.
I always try to look for something that's firmly based in real science first. And if I can't find something that is an extrapolation of science that we know and understand well today, then I get more speculative.
And that speculation is where the science fiction flourishes. Michael Okuda is the Star Trek Scenic Art Supervisor and Technical Advisor. He helps writers turn Heisenberg compensators and subatomic creatures into good stories.
Sure, because remember, he is a creature of pure subatomic force. We don't know how that works. But
He might not know how it works, but Okuda and the writer will find a way to make it believable.
yes, and he could report back what's happening. I mean, that's a bit of a reach, but I'm sure we can find some technical reason to cover that.
With a believable story in hand, the cast and crew of Star Trek weave science fact and science fiction into a seamless story of the future. If they can convince you that it's possible, then they've got you. Take, for example, warp speed.
Initiating warp pulse. Now.
We're very much in need of warp speed. If we weren't able to go that fast, we couldn't tell our stories because we only have a half an hour, after all, to get someplace and start a mystery or postulate some problem to solve, and then another half an hour to resolve it.
Warp 1, Mr. Sulu.
Warp 1, sir.
Roddenberry's invention of warp speed travel sounds like science fiction, but it actually has a foundation in scientific theory.
The warp drive, at least, is based on the idea that space can be warped. Space is, in fact, warped by the presence of mass. That's something that Einstein demonstrated in his general theory of relativity.
That is a great story.
And Einstein isn't the only scientist to have an opinion on warp speed travel. Tell me about the day Stephen Hawking came to the set.
Well, apparently Professor Hawking was on the stage or was on the lot for a screening of his film A Brief History of Time. And he told his entourage that he would, in fact, like to visit Star Trek. And a call went to the producers, who were immediately impressed. And so they came on over, and they took Professor Hawking on a grand tour of the ship. And someone told me that he stopped by the engine room and looked at the warp drive and said, I'm working on that theory.
I call. You are bluffing, and you will lose.
Wrong again, Albert.
Hawking may still be working on his concept of warp drive.
On my order, Mr. Data, Mr. LaForge.
But the Star Trek team has their own version of how to travel at warp speed.
Engage.
You send a high-temperature plasma at a certain frequency through a sort of a magical material that we call deuterium cortinide, and that's something that, of course, we just invented that term, just made that up.
When you're that far out, you can make your own rules, and that's okay, and it's just fun. And if some kid now in public school can be inspired by that challenge, great. Keep him out of law school.
Are your navigational readings going crazy?
When the warp drive seemed old hat to Star Trek writers, they latched on to another scientific concept gaining popularity: the wormhole. It's now a key element in the third Star Trek television series, Deep Space Nine.
One could conceive of ways to warp, bend space, provide tubes through hyperspace that connect one part of space with another, and then have something move through that tube in hyperspace to another portion of space. It appears right now that these structures in hyperspace, they might be called wormholes, do solve Einstein's general relativity field equations.
The wormhole could make trips a little more convenient for interstellar travelers and bring them to Deep Space Nine. But the mainstay of galactic exploration and storytelling is the starship. They come in all sizes and shapes. It all began with the Enterprise, and a design that at the time seemed very futuristic.
The Enterprise in 1966 was a flying saucer with some aircraft-style struts holding up the warp drive and the engineering section.
The Enterprise was fueled by a substance almost unheard of at the time: antimatter.
Engineering, maintain full power. Full power.
Dilithium crystal circuits failing, sir. We'll have to replace it.
Not now.
It was exotic, mysterious, and seemed like pure science fiction.
Check the bypass valve on the matter-antimatter reaction chamber.
Actually, it was founded in scientific theory. In the 1950s, the controlled annihilation of matter and antimatter was recognized by German scientist Eugene Sanger as a potential source of rocket fuel.
The nice thing about it as fuel is that a very small amount of antimatter corresponds to a large amount of energy. So that, say, a gram of antimatter could in fact be enough energy to launch a modest-sized rocket ship off the Earth and into space.
NASA could send a whole fleet of starships into the galaxy if it could locate just a couple ounces of antimatter. But with today's technology, even a gram of antimatter is extremely precious.
We make 10 billion antimatter particles per hour. Suppose we increase that by 1,000-fold. It would take us approximately 1 million years running 24 hours a day, day and night, in order to make not a gram. I think I calculated about 1,000th of a gram.
But what if we could find an economic way to manufacture antimatter fuel? Would our starships look anything like the Enterprise? This is Captain Jean-Luc Picard's quarters. Spacious, comfortable. Tea, Earl Grey, hot. It looks more like somebody's personal apartment than the sleeping quarters of a NASA astronaut, even by current standards. But without the physical or technological limitations of real space flight, one can spend a little more time in space on creature comforts. The Enterprise looks impressive, but when considering the practical needs of a real starship, it's out of proportion, according to Dr. Morgan.
What I see is a very large portion of it being devoted to crew space, scientific instrumentation. I see very little of it that is devoted to the storage of propellant or even antimatter. Now, the kinds of things that one imagines in regard to antimatter propulsion that go to the stars are going to consist mainly of a tank of hydrogen and some kind of tank, if one can produce it, of antihydrogen. And the payload of the spacecraft is going to be very small in comparison.
So a small starship is fine for science fact, but for science fiction, you need room for a cast, crew, and equipment.
The film camera and the film camera dolly require a certain amount of finite space. Unless a set is really intended to be cramped, like two people crawling through a tunnel, you try to make the set as large as you can to accommodate the equipment so that you're not constantly moving walls in and out in order to put the camera where you'd like to see it.
Red alert!
Zimmerman's fictional starships are a far cry from the pragmatic designs of a real scientist, but they do look good. Compared with the sleek lines of the Enterprise, even Morgan admits that his starship is a little clunky.
You know, when one actually makes something like this sometime in the future, as I think maybe we will, it might look very different than how I've depicted it here. It certainly wouldn't have quite as much color as I have put in here.
Designing a starship or a space station is one thing. Building it is quite another. NASA engineers would use advanced materials and high-tech instruments. On Star Trek, Zimmerman and his crew do it a little differently.
The flooring is vinyl that looks like metal diamond plate. The rest of it is built out of wood. This is again vinyl diamond plate, and the sides are actually some plastic objects that are used in the chemical industry to break up sewage in septic tanks.
Deception is a key to designing for science fiction.
You can take what is familiar and turn it upside down, and it doesn't look the same. It still looks familiar, but you're not quite sure what it is.
A nutmeg grinder. The sockets of a fluorescent tube fixture mounted on salt shakers. And a row of high-tech potato peelers. NASA isn't the only space agency searching for cost savings. The Federation relies on the industrial designers of the 20th century.
The research and development in designing a chair is really a whole lot of trouble and very expensive. We normally buy automobile chairs and then put a casing around them. That works very well.
Making the scene look futuristic and high-tech is a constant challenge for Zimmerman.
We use a lot of what I call electronic wallpaper. We use backlit graphics. These panels light up, they blink, they have moving graphics on them.
When it all comes together, the design of a Federation starship is very impressive, even to the U.S. government.
Some of the members of a company called SAIC, it's a civilian branch of the Defense Department wanted a command center that they were going to build in Arlington, Virginia, to look like the bridge of the Starship Enterprise. So December a year ago, 6 guys in suits came out and interviewed me.
Captain, the Borg ship is closing.
Arm the photon torpedoes. Torpedoes armed. Fire the photons.
The Starship Enterprise is equipped with a 24th century arsenal of armaments to defend against an army of unsavory belligerents.
Phasers locked. Fire!
The term phaser seems vaguely familiar, like much of Star Trek techno-speak. It sounds like an advanced laser of some sort, a powerful laser with a really big wallop. But what kind of energy are we talking about? Lawrence Livermore National Laboratory is the home of NOVA, the world's highest peak-powered laser.
When it fires, it puts out a peak energy that's on the order of 1,000 times all the generating capacity of the United States dead shorted together at once. Now, it's for only a small fraction of a second, but an enormous amount of energy.
Making a big laser is one thing. Making a tactical weapon is something else. Science fact or science fiction?
We are now capable of building in fairly small packages, and by small I mean easily small enough to fit on a ship, or now even small enough to fit on an aircraft, high enough power lasers that we can actually put them on a target and destroy missiles.
But will 20th century technology be able to pack the wallop of a Star Trek personal phaser into a small handheld laser-powered weapon?
Over the last 4 or 5 years, we have been developing all-solid-state laser systems similar to the revolution in electronics, where we went from vacuum tubes to transistors. Lasers are going under that sort of transition, and so the potential to having a high enough power laser system that you can actually hold in your hand is very real.
A handheld laser weapon may be within reach, but will it have a stun setting?
Set phasers on stun.
A phaser on stun. Now that's a different question. There you've got to send out some kind of beam that somehow interferes with our nervous system in such a way that it makes us unconscious, but there's no permanent damage. Be real nice to have something like that, but I don't see how that can be done. I wouldn't be surprised if someday we could do something like that.
Getting from place to place in the 24th century is no problem with the handy transporter. In the Star Trek universe, one is disassembled, transported anywhere within a 24,000-mile radius, and reassembled right down to the last DNA strand. No problem for a special effects crew, but a scientist might have a few questions.
The problem of putting together, complex molecules like DNA is awesome.
I always had a dreadful fear that if ever I was dematerialized, that I would never come back again whole.
Engaging interlock. Buffers in sync. Oh, wait a minute. Oh, no problem. Energizing. Ridge, you're up.
Aye, sir.
There is this issue in physics that's called the Heisenberg uncertainty principle, which basically says that you can't simultaneously know the position and momentum of a given particle with arbitrary precision. So if you wanted to transport somebody, presumably you'd have to map out every last atom and particle and electron in their bodies.
Engaging interlock.
Disassemble them and then reassemble them at some remote location.
Buffers in sync.
According to Heisenberg, you can't quite map that out.
Phase coils are...
I'm sorry, I just can't do this.
We've got devices in the transporter called Heisenberg compensators that take care of that, but of course, we have no idea how you would build such a thing.
Number one, good luck.
The complexity of taking a Curtis, molecule by molecule, transporting them huge distances in no time, presumably, then reconstructing all those molecules and not getting it wrong so you come out someone else. I mean, who knows? You might come out Carl Sagan or or Farrah Fawcett, or some linear combination, which would be even worse. You worry about mistakes.
Jackson, where are the others? The man is dead.
The Wright brothers just didn't happen to go out and put some wings together on a bicycle and say, gee, I wonder what this is good for. It was the vision of being able to fly that really has driven people. And now I think that's just the vision of being able to really live, explore, open space is the next vision. And what's exciting about that is it's limitless.
The appetite for wondering about the future is insatiable. I am certainly one who hopes. I am filled with hope. And this show certainly talks about that there is hope.
Star Trek has created a future in which our children and their children will be the new explorers of tomorrow, with distant worlds to discover. It's a future where science and technology are the tools used for the good of humanity and those we encounter along the way.
Beyond 2000 Next continues our Space Week programming with a look at developments in outer space.